And the first question I would like to start with, it goes for you, Eric, is in relation with DDD, because you are supposed to be, well, the creator, more or less, or the main or principal architect of this set of concepts. So could you highlight the advantages, the main advantages of this architecture in comparison with others? And in case there is a canonical example which fits perfectly into this, can you give us that example?
I think that what we tend to do as software architecture people is focus on all of these important technical concepts. And what domain-driven design says is we have to shift the focus back toward the actual domain we're working in, but without losing our technical sophistication. So it helps us focus on that, on actually collaborating with business people or with engineers or whoever your domain experts might be, to create software that really fits what they're trying to accomplish. And there are tools both at the tactical level and the strategic level for doing that. At the strategic level, it looks at ways of actually identifying the most critical part of what you're doing and improving the design in very specific areas. And I think that that whole toolkit is what domain-driven design brings. I would say that there are examples on the website, like on the DDD community.org website. There are several practitioner reports, real projects that have applied domain-driven design, and they have some good examples there. There's also a thing that you can find on that site called the DDD sample application, which tries to show ways of implementing it. I think Udi might not like some of those ways.
In relation with this, do you think domain-driven design is incompatible or complementary to cloud-based solutions? Because you know how important is being the cloud lately. So that will be about the point. It's for any one of you.
I think on one level it's almost irrelevant. That is, I would apply DDD regardless of the nature of the deployment environment, because it's really saying we have to focus in on what our business problem is, develop this shared language with the people who work in that, and then find a model that really sharply addresses it, and of course is implemented well in whatever the implementation platform is. So I want to find a solution that works well on the platform I'm going to work on. Now that cloud is becoming a significant platform, that would guide me maybe towards slightly different models than the ones I would have chosen when things were a little more monolithic. But I don't think it's going to determine my decision about whether to apply DDD or not. It just will change. It might change the particular style and model I would choose. But actually, I would like to hear Udi talk about that one.
So, unfortunately, when we talk about cloud computing today, it's kind of like SOA was maybe 5 years ago, where a large number of very big vendors got very interested in this term around the same time, and each one of them kind of took it in their own direction. So you have Amazon with Amazon Web Services, one of the front runners in terms of what their cloud-based offering provided. Since then, you had a whole number of other vendors that jumped into that space. You have Microsoft with their Azure platform. You got Google that provided something that is higher level than even Microsoft provided, but limited you in terms of programming languages and patterns that you could apply in there. You had a whole bunch of smaller vendors jump in there, including App Harbor, that are kind of in the middle between, say, an Amazon Web Services and a Microsoft Azure. A lot of them looked at it from an automation perspective, the automation of deployment. Very useful techniques, but don't necessarily touch on how we identify and model the business problem at hand. And then you have the on-premise vendors that have, I'm not sure if I'd use the word subvert, but they have interpreted cloud to also include what's known as the private cloud, which ultimately means that you can deploy a cloud to your on-premise infrastructure as well. So, and you have VMware with their type of on-premise cloud offering and EMC, and ultimately everybody is jumping over the cloud to sell their own products. But as Eric was saying before, this is very much a deployment-centric concern, more so than a how do you design your software, how do you target the problem domain to begin with. Occasionally, there may be some relevance, for example, with regard to scale. If you're trying to solve a business problem that needs to support many millions of concurrent users at the same time, that's not something that you can shuffle off and say that that's just a deployment concern. That is going to have an impact on the way that you think about your business. Facebook would not be the same Facebook if it were 100 users that were friending each other at the same time. So the quantities and the scale do have an impact on the business boundaries that we look at and the type of analysis that we do. But I wouldn't say that that is specific to the cloud. That is something that any company that deals with scale has to address.
You say CQRS is not only for high scalable apps, but also for collaborative apps. Could you explain that concept of collaborative apps and give some examples about it?
So one example of collaboration that I often use is a reservation system. So this could be a ticketing style application, say purchasing tickets to a football game. You have lots of users that all of them at roughly the same time would like to purchase tickets to the exact same game. Everybody wants the best seats. It's not collaborative in the let's all be friends type of scenario. It's a whole lot more competitive. I want the best seats so that you don't get the best seats. So trying to solve this kind of problem, it becomes more difficult to use traditional techniques to solve this as the scale increases. Like I said, it's not only in those kind of situations. The ticketing example is one of the better known examples where it is clearly exposed to the end user that I am operating on a data set that is being operated on in parallel by other users. A whole bunch of other scenarios tend to be a whole lot more low-key and in the internals of the business logic of the system. One indication that in even a relatively small-scale system, you have some collaboration going on, has to do with race conditions. So anytime developers uncover some kind of race condition, when user A is doing activity number 1 and user B is doing activity number 2, and the business requirements somehow put these two users at odds, and we find that that's a race condition, ultimately there's some collaboration going on. Ultimately the business is saying there's a relationship between what this user is trying to achieve and what that user is trying to achieve, and what I as a business am interested in promoting or preventing from happening. And I need to find some way to balance all of these forces. CQRS gives me ways to ask business stakeholders the appropriate questions. What are you trying to prevent? What are you trying to achieve? And to balance the various user intent. And to come up with a certain type of model that is usually driven by sagas. Sagas are a specific implementation pattern that allows us to balance a lot of messages or events that need to be handled in parallel in a stateful, consistent manner. So even at smaller scales, we can see race conditions happening. We're primarily looking at not a scenario where the business says, well, if it happens, no big deal, I'm not worried about it. But rather when the business rules need to enforce that, well, we can't actually have it both ways.
In which scenarios you would not use CQRS?
I talk about that quite a bit now, and so does my co-conspirator around CQRS, Greg Young. Both of us feel like we pushed the CQRS pendulum a little bit too hard, and now people are overusing it and abusing it. I'd say that a lot of the traditional data in, data out crud or I think it's called crude here, type of technology. If all you need to do is get some data from the user, persist it to a database, and show it to the user back again on another screen, you don't need CQRS. I'd say maybe you don't even need a domain model. You just have some flat data, store it, get it back out again. And a lot of times people assume that when I say don't use CQRS, they believe the alternatives to go back to the multi-layered, multi-tiered type of architecture. And my recommendation is not only don't use CQRS, don't use multi-layer, multi-tier architecture. Go back to the simplest, stupidest two-layer client-server architecture. It works great, it's simple, it allows you to get it done fast. It often performs a whole lot better because you don't have to serialize and deserialize through XML 5 different times. So I'd say in a lot of very simple data management bounded context, to use a DDD term, just the simplest data management solution, use that. Don't use CQRS for it.
Many architects care much about modeling and wonder about the best choices, because there are several. What are your recommendations? I mean, the classical UML or the most modern DSL or just plain code? What's your opinion about that, for any of you?
One thing I want to emphasize is that when we say model, we don't mean UML diagrams or any artifact like that. We're really talking about these well-defined abstractions. So they're not physical things. They're conceptual. They're just concepts and rules about those things. But then, of course, we have to manifest those. We have to express them in software. So then we create some objects and or what have you that actually are an expression of those concepts. Now, we also like to communicate about these things, and that part we have to have, because if that's what it's all about, is software that works and expresses a model that makes sense to us. Now, we want to communicate about these things, and so sometimes it's easier to communicate about something with a diagram. So sometimes we draw a UML diagram, maybe especially when you kind of want to show someone the relationship of different things. Diagrams are really good at kind of showing how these different objects relate to each other. More, that fits graphically. But sometimes you want to describe, say, some invariant, a very important thing that's always true in your model. And a lot of times that's much easier to describe in words. So you choose the way of communicating that works well. And you say, my purpose here is communicating with another person, the other developers or the business people. And when we start talking about DSLs, though, we're saying what we're trying to do is create a programming language that will let us say those things and then it will actually execute. And that's a more specialized technique. So whereas I would always, in any project, I'm going to have very carefully defined terms that I'm going to use in writing down some documentation, isn't that? And that will closely correspond to the classes and the other artifacts that I have in my code. But actually having a DSL where you can write some things and then it will execute, that's something that I would only use in pretty special situations.
There are two concepts intimately related to domain-driven design. One, you've been talking about that in other interviews that I've seen. One is ubiquitous languages, and the other one bounded context. Can you briefly explain the difference and the importance of all those concepts?
All right. Those are two of the most fundamental principles. So I'll start with bounded context. The truth is that there's not one model of your domain. There are probably an infinity of possible models, and there's a multiple number that you're actually using. Maybe you have different departments in your organization, and the different people think about that model and think about that domain in different ways. The sales people think one way, the marketing people think another way. Maybe you have different subsystems in your software. Here's a module you built 10 years ago. Here's a module that you bought off the shelf. Here's a module that you're just building now. Each of those is going to be based on different conceptual principles. If you ignore that, then you just start tangling together everything. You end up with a muddled, confusing mess, and you don't get the benefit from modeling. So what we say is we want sharp and clear conceptual models, and to do that we need a boundary. We need to say this model applies within this context. It could be defined in various ways. I tend to define it with subsystem boundaries more often than not, but that, of course, even what a subsystem is, it's a poorly defined term, I readily acknowledge. It just has to be some way I can say, this is where, if I have an object I call customer, because I can never think of something better when I'm sitting here, order, okay, I'm ordering something. Order is defined very precisely in my model, but it applies within this boundary. Now, I have more than one of those, and sometimes I'm just observing the way things are. I don't choose. We've got this other piece of software that we integrated with, and it is different. We didn't have a choice about that being different. There's no chance that someone who independently developed a piece of software is going to come up with the same model that we did. It just wouldn't happen. So we know that one's a different context and maybe more than one. But sometimes we consciously choose. We say, well, I'm working in a couple of different subdomains here, different parts of my business. Like, here's the marketing part and here's the sales part. And we want to address these differently. And so we want the freedom to create a model here that is really good for sales and create a model here that's really good for marketing. So those are the kind of bounded contexts that we have chosen. And Udi talks a lot about those. I think that's the one that kind of you mostly enthuse about. Whereas I tend to talk more about those kinds that are imposed upon us.
Right.
But still, both kinds are important. That's bounded context, is saying we have different models and we want to be very clear about where we're using them and try not to mix them together. The next thing you mentioned is ubiquitous language. Ubiquitous, of course, I think one of the downsides of that term is it makes people think of an enterprise model. It makes people think of the opposite of what I just said. Everyone's going to say things the same way. But that's not really what we mean. In fact, I would say that a ubiquitous language applies within one bounded context. But what it's saying is that within that bounded context, we have one way of saying something, and we all say it the same way. We don't have like 2 or 3 sub-languages. I don't have a way that I talk about the problem when I'm writing code, another way that I talk about the problem when I'm talking to my business stakeholder, maybe another way when I'm writing the spec. I have one conceptual model and one set of terminology, and I try to keep that very unified, but only within the scope of the bounded context. Over here, in sales, I have a different one. Maybe I have a different ubiquitous language. Now, ubiquitous language falls into that tactical level where, I mean, it's one of the sort of high-level tactical ones, but there might be a context in which I'm really just not trying to accomplish those kinds of goals. The reality is we have 2, 3 different languages. We talk to the business people one way, and okay, we're not going to be able to make everything great. We have to focus our efforts. But once we decide within a particular context that we are going to try to apply the tactical level of DDD, we are striving for that ubiquitous language, which means that when we realize that we always say, you know, when we're talking to the business people and they say customer, they mean this they mean the people that they interact with when they're trying to sell something. But when we look in the software, it's the place that the invoice gets sent. And so 3 or 4 different things that they would call customer all grouped together because they're all invoiced together. So what is a customer? Well, we better work that out if we want a ubiquitous language within that context. On the other hand, if marketing identifies a customer to be a much, let's say, a bigger kind of entity than sales does, that could work fine. We'll need to we'll have some translation work to do, but so that's why ubiquitous language and bounded context kind of go together.
What would you say is the best solution nowadays? At the time I'm making a deep analysis of an application, let's say a middle size, using CMMI or agile techniques?
Well, so I try not to be too prescriptive about the process, but I will say this. You need to be able to iterate. You need to be able to go back, and by iterate I don't mean increment, I don't mean build a feature and add another feature and add a feature. I mean you need to be able to go back to software that already works and change the way it works, to move to a new model, a new way of thinking about the problem. If you're trying to accomplish those, if you're doing ubiquitous language and the other tactical view of DDD. The reason I say that's so important is because modeling is a learning process. The model you come up with at the beginning of your project will not be very good. If you spend more time at the beginning of the project refining the model, it still won't be very good. So it's better to get going and learn and learn and learn. And as you learn, you keep changing the model, you change the model again, and you change it again. That's the only way that I have ever seen really good models emerge. And that is a thing that Agile people emphasize. But they also emphasize some things that don't help so much, like an extreme focus on one feature at a time. I worry about this feature, and that's all I'm supposed to think about, and then I worry about this feature. That tends to fragment the model. So Agile, as it typically is interpreted straight off the shelf, doesn't fit that well, but I think that the toolkit of Agile is still probably a better starting place because it does emphasize the iterative nature.
Do you think NoSQL databases fit better in the middle of CQRS? In comparison with relational databases?
So, I'd say non-relational databases have, so a lot of them are schema-less. In other words, you do not have to define upfront what the schema of the data that you're going to store is. Ultimately, you can just give them some data and they'll persist it. They have indexing capabilities that can allow for very fast retrieval, similar to a standard relational database. But I'd say that the schema-less nature of those types of storage techniques gives us flexibility in terms of in version 2, 3, 10, 20 of our system. When the model and the business needs have moved in a very different direction from what we originally started with, having to redo a schema at a data storage level at the same time that we are restructuring our model is a great deal of friction that we end up having to pay every single time. If we could only change a model without having to change some other schema, that is less work that we need to do, that's less duplication of definitions, allows us to more quickly take our system in a new direction. That being said, I wouldn't recommend taking a traditional layered architecture that is built on a relational database, ripping out that relational database and putting a NoSQL database in, because a lot of the NoSQL databases are transactional. And a lot of times, we need transactions. We require consistency. So a very big part of my position on non-relational databases is that when you take a system that you have full control over, you can identify bounded context, and Eric was alluding to that before, is that what I like to do is to divide up a system that I have full control over into very small granular chunks, where in discussion and in collaboration with the business, I make sure that the boundaries are such that the business does not require consistency between one bounded context and another. In that sense, the business is telling me they do not require transactions between A and B, in which case I can have smaller independent databases behind each one. Often what comes out of that is that the data in each one of these doesn't have nearly as many relations as the traditional monolithic database that supports everything. Often then we can use something like document databases or key value stores that, while they can provide us transactionality at a relatively small level, I don't need full monolithic distributed transactions like the bigger, more heavyweight technologies give me. So often I get smaller databases, schemaless, easier to maintain, faster to version. Often this gives me better performance as well. Rather than having one big database, now I can have 10 little databases that are processing transactions in parallel. It's a whole lot easier to scale that if my needs require that. So there are a lot of things to like, but it starts with dividing things into bounded contexts. So until you do that, I wouldn't say throw away the relational database.
Which is the position of entity framework in relation with DDD and CQRS?
The thing is, entity framework, the product I work on, is an object relational mapper, and as such, I think that the main goal for it is to do its job and get out of the way. Especially when you are building something, an application using DDD, and you chose to use a relational database and you have a domain model, the role of something like entity framework is to provide the service of persistence. And there are several options, there are several ways a persistence framework can work, and being a fundamental part of the infrastructure for the application, it's very important that the way the framework works doesn't leak into the rest of the application and doesn't leak into the domain model. So long time ago, when we started with entity framework, we actually had a few issues around that. And we learned a lot from people in the community, especially from people that practice DDD in the community, and from Eric also, and other people that we talked to. And we learned that we needed to reduce the friction and to create something that could allow people to basically do all the practices of DDD and just have a very simple way of storing their objects. And that's what we try to do. Lately, we have created things like what we call the code first experience, which consists on just a way to model your domain the same way you would do it normally, just for the sake of modeling your domain using code. And based on a number of conventions and configuration APIs that the entity framework provides, you can use your objects, the objects that you created for the domain, directly to persist those into the database without like having additional artifacts, XML, or any additional overhead. And it allows you to also create your different models, like create separate domain models if you need to have several domain models in the same application. It allows you to model different bounded context, basically because it gets out of the way. That's what we believe we have provided. And lately also, I believe, once you choose to use .NET, I think it's one of the easiest to use options that you have in this ecosystem.